Okay, guys, this is our 7.3 assignment over groups and periods, also known as the periodic law. And this answers the question, on the periodic table, what do elements in the same columns have in common? And what do the elements in the same rows have in common? There's a reason for the way the periodic table is arranged, okay? They're organized by increasing atomic number and increasing number of electron shells. So we'll kind of take a look at that as we go here. So first of all, I want to make sure people know that the periodic table was created in the late 1800s by a man named Dmitry Mendeleev. Now, he didn't create this alone. He used an existing model, but he sort of arranged things the way we know that they're arranged now, by atomic mass and then by their electron arrangements. Of course, in 1913, Henry Moseley arranged them by the number of protons instead. But the periodic table we have now, we owe a lot of that to Mendeleev. You guys should look up Mendeleev. You should learn about Mendeleev. He had a fascinating history. He was basically born on a poor dirt farm in Siberia, and he came to tell us a lot about the nature of our reality. So, the periodic table is arranged by groups and periods. Groups and periods. Periods are the side to side. They are the rows of elements that have an increasing number of protons and electrons. So as you go from hydrogen to helium, you get another proton, and in a neutral atom, you get another electron. Lithium goes to beryllium, goes to boron, goes to carbon. Every time we take a step to the right, we are adding another proton. And you'll notice that these rows end, okay? Each of these rows ends, and we're going to talk about why that row ends. But for now, it's enough to know that the side-to-side row has an increasing number of protons and electrons. Okay? Each row in the periodic table, it ends when the outside shell is full. Okay, I'm going to show you guys what that looks like. So we're going to skip over hydrogen and helium here. We're going to go to lithium. So here we are, the beginning of row 2, the beginning of period 2, right? And you'll notice there's one electron on this outer shell. As we add protons, we need more electrons. Now there's 2 electrons on the outer shell. Now 3. As we go to boron here. When we go to carbon, there will be 4. When we go to nitrogen, there will be 5, and then 6, and then 7, and then 8. Okay. So as we move to new elements, as we move to increasing elements with an increasing number of protons, then the outer shell fills up. But the outer shell can only hold so many electrons. Once it's full, we start a new row. Now we're in the 3rd row of the periodic table. We're in the 3rd period. That's why it's called the periodic table. It's a table that's arranged by how many electron shells that the atoms have. So periods are the rows. Okay. Here we can see this sort of ignores the protons and neutrons. It just shows how many electrons there are in the shells of these different kinds of atoms. Hydrogen has 1, helium has 2, and then that shell is full. Remember, the first shell only holds 2 electrons. And then lithium has 1, beryllium 2, just like we just showed you, just like I just showed you. Okay. Now, this just shows what I was just talking about, how each row has another electron shell. Okay, and each of these periods ends when that shell gets full. Now we're going to talk about groups. A group on the periodic table is a column of elements that has similar properties. It has similar properties. So group 1 would be hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. It has similar properties, but there's a reason why these atoms have similar properties. That means that they act similar. They react with the same kinds of other elements. Okay? Lithium will react with fluorine much the same way that sodium will react with fluorine, much the same way that potassium will react with fluorine, or chlorine, or bromine, or iodine. Okay, so there's a reason why the elements in a group have similar properties, and we're going to look at that in our periodic table of Bohr-Model. So here we have sodium. Okay, well, let's go back. Let's go to lithium. Okay, well, notice how many electrons are in the outside shell of lithium? Just the one here. Okay, so we're going to go all the way down. We're going to go all the way to sodium. Okay, so this shell gets fuller and fuller and fuller. Now we're at sodium. It's directly below lithium. It's in the same group. Now, notice how many electrons are in the outer shell? There's just the one. So elements in a group have similar properties because they have the same number of electrons in their outer electron shell. Okay, so looking at our periodic table, group 1 has 1 electron in its outer shell. Group 2 has 2 electrons in its outer shell. Now, this particular periodic table makes things confusing because it doesn't list the group names here. But we sort of skip over these. We pretend that these transition metals do not exist, okay, for this discussion. And we go to group 3, then group 4, 5, 6, 7, and 8. Every time we change groups, we add another electron to the outer shell. Sodium has 1, magnesium has 2, aluminum has 3, 4, 5, 6, 7, and 8. So as we count up the periodic table, we get more electrons on the outer shell. And as we count down the periodic table, we get more electron shells. And of course, it's worth noting that electron shells, they seem to take up space. So the elements down here are physically larger. They have a greater volume. They're bigger size than the atoms up here. And so that is the arrangement of the periodic table. That is the periods and groups of the periodic table. And here you can see group 1, group 2, 3, 4, 5, 6, 7, and group 8. Okay. Group 1, you can see here it has 1 electron in its outer shell. Group 2, it has 2 electrons in its outermost shell. So now the self-check. Question 1 is, what do elements in the same group have in common? So if they're in the same group, remember, they have the same number of electrons in their outer shell. Okay, group 1, lithium and sodium, they have 1 electron in their outer shell. Group 2, which would be boron and beryllium and magnesium. Sorry to get that confused. Group 2 would have 2 electrons in its outer shell. Group 3, 3 electrons in its outer shell. So that tells us, the elements in a group, they have the same number of negatively charged particles in their outermost electron shell. Now, groups in the same period, look at this chart, this will be easier. So period 1 elements, okay, they have 1 electron shell. Period 2 elements have 2 electron shells. Period 3 have 3, and so on. So then elements in the same period have the same number of electron shells. As we count across the periodic table, lithium and everything to the right of it has 2 electron shells. Sodium, everything to the right of it has 3, 4, 5, 6, and 7. Now, question 3 asks, what period is NE a part of? So we'll look at NE here. We'll use this one. Oh, I could actually use this one. NE is neon. Okay. So neon is right here. What group is it a part of? I'm sorry, what period is it a part of? It is part of period 2. It has 2 electron shells, so it's part of period 2. It has 2 electron shells, and it's in the second row. Now the next question is a little tougher. It says, what group is neon a part of? Well, to know what group an atom is part of, you just count the number of electrons on its outer shell. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. We can confirm that with my periodic table of Bohr models as well. Those are the wrong way. Neon, it has electrons on its outer shell. Now we have to ignore the transition metals for this understanding to work, to understand groups and periods. Transition metals, they sort of break the rules. If you remember back when we were talking about how electrons, they move in shells around the outside of an atom, they move in shells. And I talked about how they actually move in something that's more like a cloud. Well, transition metals are the reason why we have to have that understanding. They're sort of what taught us about that. We're not going to get into it. It's just not worth discussing at the physical science level. Now, when we, if we transition into more of a chemistry curriculum, we'll need to know more about orbitals and suborbitals and that whole thing. For now, it's enough to just say these transition metals don't exist when we're talking about groups and periods. Okay. All right. So hopefully now we understand why the periodic table is laid out the way that it is. Okay. Group 1 electron shell in its outer. 1 electron in its outer shell. Group 2 has 2 electrons in its outer shell. Okay. And 3, 4, 5, 6, 7, and 8. All of these have 8 electrons in their outer shell, except helium, of course, because that shell only holds 2. Hydrogen and helium are sort of weirdos. And then for periods, we have 1 electron shell in this row, hydrogen, helium, 2 electron shells for lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, 3 electron shells for sodium, magnesium, and all these. Okay. And then 4, 5, 6, and 7. Okay. So that is the periodic table, and that is the periodic law.